Good afternoon, and quick happy Canada Day to you all. And I'm going to head into a discussion about Ethernet fiber cement panels as ventilated rain screen. There's quite a bit of content for 30 minutes, so I'm going to move fairly quickly. And if you have questions, there's a question bar on your GoToMeeting tool control panel, and you can ask a question there. And I will check every once in a while to see if any questions were asked. So here we go. So Engineered Assemblies is involved in the design of facades and other building envelope components. We represent products, and we do that across Canada. And then in Ontario, we have an install company. And why that matters is you can trust the details I'm going to talk to you about today because we're out there building based on it every day of the week. The trends in design that we're reacting to and trying to lead is better design, and you're being challenged to build better buildings. Codes are changing, and also owners are asking for better aesthetics to help represent their buildings. And that's a key aspect of everything we're going to talk about. Ethernet is about brand. It's a name. It's about a manufacturing process. It's about local and global because it's what happens. It's a very global product. And it's about something that's perceived to be new, although it's very historical and been around a long time. It's kind of one of the fun things of representing this product is that people think it's brand new when really it's been around for decades and decades and decades. Now, what's new about it, before I get into details, is Ethernet's launched a new brand called Equitone. And that's because the word Ethernet in Europe is very generic. It's been around for over 100 years. So, in order to distance themselves and build their brand, they've created this brand. We've been launching this very slowly because we don't want people to be confused. Ethernet isn't generic in Canada. People find that word new, but they kind of remember it. Fantastic company. The other thing that they've launched is a new color, and this is the what we called Ether Color before. They've now called Tectiva, and this dark gray panel. And when I saw that in Europe, took this picture right away and got it on the web. It's awesome, and we can get you samples on that by just simply requesting them on our website. So fiber cement is a lot about visual impact, face and personality, and high involvement. So the research that ETEX Group has done about fiber cement is really all around the designer. It's not just a building material. And it does come from the concepts in architecture, which you would know much better than I, but about simple, straightforward construction and design that the building represents what it is, as opposed to ornamentation or cosmetics. So fiber cement, aesthetically really interesting, but it's designed and the company keeps thinking about working it into buildings that are very simple and straightforward. It's used in what we've called rear ventilated rain screen, also known as ventilated rain screen. It's typically a panel. They come in 4x8, 4x10, fastened to girts on the outside of an insulation layer. And I'll be in greater detail as we go. The attachment methods vary. However, in essence, the aesthetic is all about this type of panelized product. And the concept of having a skin on the outside of the building, or what we call rear ventilated rain screen, is all about this. And this is how fiber cement really meets all of these requirements. So the panel on the outside is taking all the abuse of the weather and protecting the building inside from solar loads, the heat, the noise, even cold, wind, etc. It also means your insulation is always drying. And this ventilated facade concept is removing water and vapor in a very active, natural manner. So this isn't just a drain cavity like in the brick world. This is a truly active plenum. And the fact that this panel has been developed to be so strong, even though it's very thin, is a fantastic value proposition when you think of proper use and of materials and preserving our planet. So there's quite a bit to this, I guess, is what I'm getting at about how this meets a ventilated facade. So now into the details on Ethernet. The number one thing and reason why people choose it is its beauty and how it leans to rather innovative architecture. The fun thing for Canada is, even though it's innovative architecture, the material's been around a very long time. So over 75 years. It is made in very, very large quantities around the world. And by this particular company, which is the largest manufacturer of fiber cement. It is very simple. Line 1, it's Jose. Eric, line 1. Sorry, that's just the phone. It's very simple, very light, has low embodied energy. It's very strong, natural, and easy to use. We'll explain what that means. So you can do really interesting, ornate things like this, but you can also do very simple things. This is the factory in Germany. So I'm just trying to make the point about how this isn't two guys in a garage in Mississauga trying to make something together. This is a huge production business, and they ship pallets and pallets of fiber cement all over the world for walls, roofs, etc. It is simple and natural. This is sort of a closed-up version of one of the more raw-looking products. One of the things I want to be getting across to you is that part of its strength comes from the fact that it's very homogeneous. So as you can see, there's really isn't layers per se, and we'll talk about why that is. Getting into a higher level of detail, there are through-colored and coated products. There are 80 plus colors and 5 different finishes, so there's quite a bit of choice. There are different thicknesses, and fundamentally, I mean, you could make fiber cement in any thickness. When I show you the manufacturing process, you'll see why. These are the thicknesses that have proven out over time to work. 5 mil for interiors, 8 mil for front fastened systems, and 12 mil for concealed fasteners. It could also be made in any length, but these are the sizes that make the most sense for constructability and be able to ship it, etc. It's packed in wooden pallets and standard containers, so shipping is very straightforward. It has a number of install choices, face fastened with rivets, rear hung with adhesive, and rear hung with aluminum hardware. It's very simple to cut. It can be cut in the factory or on site. We've done both. And you kind of think of it like fine hardwood. The person cutting it's got to have some skill, but it's pretty straightforward. And then some of the accessories that go with this system are an EPDM liner on the girts, galvanized steel girts, rivets, a rivet sleeve, which I'll show you, and tools. Fiber cement is made of very simple materials. Portland cement, sand, water, and cellulose, textile fibers. It's not concrete. And the difference between this and glass fiber reinforced concrete is that it's fiberglass. It also has aggregate that comes from making concrete. And that introduces all sorts of other contaminants and materials systems that aren't repeatable. It's made in such a way called the Hashik process. And there's a lot to this document, but I'm going to make a point about why this is important in a moment. So the mixing of the materials means that we end up with a very homogeneous product. And that slurry of material enters the panel forming machine, or also known as a Hashik machine, and whereby the panel is built up through almost like the paper industry with big rollers, and the strength is built up with that, and then therefore is put under pressure and cured, and now you end up with a sheet that's flat, straight, and strong. And this machine is called the Hashik process. So that slurry of cement, sand, water, and fiber goes into these vats, and different amounts of it are applied to a piece of it, and as it spins around this conveyor belt, it gets thicker and thicker, and when it's at the right thickness, it's cut and then put under pressure and cured. Why that matters is it's just such a simple manufacturing process. They can make it in very large quantities. This isn't a batch process where they lay out panels and layers and have human interaction that can vary from one panel to the next. It's a very automated process. And this is a picture of the Hashik machine in one of their factories. So it's the innovation of a Hashik machine was that this gentleman in Austria saw how paper was made, and you think about how strong paper is for its weight with these large wheels and making very homogeneous solution. Uh, he thought if he changes the materials, could he make a building material? And that's where the concept comes from. And this concept of having a very homogeneous product, and this is a microscopic view of the actual product, means that it's very strong. And I lead right on to this chart that shows you that the tensile strength and bending strength in both directions are pretty much identical. And that's a key to making it usable on all sorts of buildings. It means in the hands of a skilled person, whether it's horizontal or vertical or on a soffit or whatever, it's is very strong and very um, rugged. The fibers, you can read this chart about the fibers. In essence, what the fibers do is give it some of that long, tensile strength, and it also allows it to create a frost resistance, moisture regulating, breathable product. So water can get in, water can get out, and it can expand and contract. Um, and being made of these very consistent materials means we have incredibly consistency for its behavior on job sites. It's also a very standardized industry, and in Europe they created an industry standard called EN 12467, and in America it's ASTM 1186 and 85, and it covers everything. And the key thing that you should look at maybe when comparing products is the bending strength for both directions and the manufacturing tolerances. And some of the batch material products like GFRC, especially some of them made in smaller companies, their manufacturing tolerances are 2 or 3 times what are made out of these products, meaning that you can't really count on the consistency from one product to another. The other biggest difference between fiber cement and the other types of technologies is the strength to weight ratio. So for this nice thin 8 mil panel, it's incredibly strong and much stronger than some of the even thicker panels. And this is a comment about that. We sometimes get a spec that says 12 mil when really all is needed is 8. And it's really about the engineering performance. And some of the other materials like GFRC or precast, they have to be that thick in order to be strong at all on the building. And fiber cement does not. The company also takes very serious its impact on the environment. And I think this is rather an example of how they think, and I think kind of worthy of their brand. They, as you know, canals and rivers in Europe were a big part of commerce in the past. Well, they actually went back to that, and they've been getting their raw materials by boat, and now they're shipping their finished goods to airports by boat, and or I'm sorry, not to, of course, not to airports, to shipyards. And they've been able to greatly reduce the environmental impact of avoiding having to use trucks. Incredible innovation, but very simple. So now we're going to jump into some of the products and talk about the products that you'd actually be designing with. And this is an example of a rather innovative design using fiber cement as actually the shutters on windows. So the colors that you're going to find in fiber cement are all very organic. They're going to be the kinds of colors that you would find in nature. They are not trying to be the colors that you might find in the aluminum business, for example. They are trying to be the colors found in nature. So, for example, these greens of this particular building, they're all very simple, natural greens. It's also a very strong product and has been used for many, many decades. It's used in non-combustible construction. It passes the CANUL CS 135, and that's useful when you compare it to many of the other building materials in Canada. It is resistant to humidity and freeze and thaw, and therefore suits our communities where that's our biggest problem. It also suits the high north, where just getting cold and staying there is fine too. It is easy and flexible to install. A picture on the left is a grocery store in suburban Montreal that I happened to be there the day they were putting up. And, the holes were already drilled in the panel, girts were up, and these two fellows were just flying like the wind as they plied these panels, because the panels are light and strong and very durable. And so the fastening system was very, very rapid. And in fact, I'll show you the picture, I think, a little bit later. The wall on this grocery store curves 90 degrees across the backside of the building, and the fiber cement panels are able to take that curve. It's also easy to clean, especially there are choices for products called Natura Pro that have graffiti coatings, which even greatly improves the ability of the panels to be cleaned. This was commented on earlier, and want to make it clear, we've developed a one rivet system. So it's important in any of these kind of panel products that you allow them to expand and contract. The way that is done is we drill all the holes the same dimension, and the rivets are all the same dimension. And then the two fixed points that are required near the center of the product, this little sleeve is put on this rivet, and that removes, that carries the dead weight. And this very simple system removes the risk that an installer is putting the panel on wrong and not allowing for expansion and contraction. There are also concealed fastener systems, so with hardware and with adhesive. And we've been using this Tweehouse system on schools, custom houses, and retail. And it's a fantastic product for the Canadian environment. There's a set of tools, very standard set of tools that contractors use to put these kind of products on the wall and cut it, and to drill it, and to fasten it with rivets. And it's been around a long time, 75 years in business. With that comes a whole lot of knowledge, and a lot of questions get answered because new ideas come up from architects, and we've had that experience and therefore can answer questions. So just in summary so far, and then I'm going to continue into some higher levels of detail. Ethernet is a technology name. It's a real aesthetic. Its manufacturing process is why it's strong, light, and durable, and repeatable. All the panels are going to be the same. It's strong and thin, and it is measured by an industry standard. So it's not just up to this manufacturer. And it's been around a very long time. Now, the product families under that brand of Ethernet or Equitone are four: Natura and Natura Pro, Etercolor, which they've now changed to Tectiva, but I'm continuing to carry both names, Textura and Pictura. And I'll explain and show you some jobs of the different textures. Fundamentally, they're made the same way. It's really the surface that changes the aesthetic. So Etercolor is a through color board that is lightly sanded along the long direction of the panel, and the colors are very natural aesthetic. And that sanding, and also the fact that you're seeing the real fiber cement, means that although the color's the same across the whole panel, the lightness and darkness varies across the panel. So you end up with a really interesting look, because each panel has a slightly different aesthetic. And this chart about color is set to explain that. So the measurement of green, magenta, etc., the typical measurement of color are the same. So when you order gray, you're getting gray, but there is a variance of lightness and darkness across the panel, and therefore each panel is unique, and you get a really interesting aesthetic with this. And so this is a picture of a job in Belgium I took. So every panel being slightly different in lightness and darkness gets a really natural cementitious aesthetic. And this is actually the picture of that job. So the use of the panel in this layout is bringing out that aesthetic. It also has a white that is whiter than anything in the industry, and it's going to stay white. UV actually makes it whiter. And this is a job in Whitby, Ontario. And that white, as opposed to, say, whitish concrete or white metal, is going to get whiter and whiter. Water is going to be washing metal off of, washing dirt off of it. and the sun's going to make the panels whiter and whiter. This is a job in Waterloo, Ontario with what's called an ochre color, and you can see a bit of that variance across the wall system. Now Natura, on the other hand, and Natura Pro, the Pro is a graffiti coating. Every panel has a coating on it, and that coating is translucent, meaning you see the fiber cement look, but it makes every panel look identical. So in this case, you can choose to have a uniform color, very consistent, non-directional, and no variations between panels. So that's an aesthetic choice, but and so different than the ether color. And this is a couple of examples of jobs. This is some construction jobs it took of the Niagara West YMCA. And it was an interesting application on the interior of the building as well. And on this wall on the left-hand side actually curves, and fiber cement can take a curve. We also cut it in a layout like this for the Milton twin pads. I'll be coming back to that. This was a recladding of an office or of a social housing project in Vancouver, and all these different pieces lined up to make a beautiful wall. This is a large job in Barrie, Ontario, and these are all Natura panels in that in white and gray as part of a award-winning project. The Europanel company, and this is something that I think you might want to keep your heads up for. Environmental product declarations are coming your way. In Europe, they're already here, and that's why these exist for this company. This is going to be a way for you or lead consultants to actually understand what products do to the environment. Instead of some of these proxies, like how far away was the product made, what is the true energy and carbon emission impact of choosing the product that you're choosing. So that's something you're going to see. I believe that's going to be instituted by the US GBC in the next year or so. The next product is called Pictura, and it has a opaque coating. So this is where you can get oranges and reds and blues and things like that. And that coating is a UV graffiti coating. It's very matte look, and it's smooth. So the pigments that are used for this are very natural in color, but this is where you can add in some bright colors. So in this particular one, the bottom 2 rows are fiber cement, and the top 4 rows are metal. And this was the job that I was describing earlier, that the panels were put on the building to create a curve around the building. Textura is got more of an orange peel surface to it, and it has the same kind of Pictura coatings. And I don't exactly know too many jobs yet because we haven't sold too many of this, but it is a beautiful product, and we'll probably see more of it in the future. Now, the alternatives I've mentioned earlier, glass fiber reinforced concrete and medium density fiber cement. Just a couple comments. So glass GFRC, like Fiber C and Sinstone, needs to be much thicker in order to be strong, and therefore it's heavier, and you're going to have more structure. Some of that structure is going to be thermally challenging because you're going to end up with a lot of girts. And it hasn't been around that long. And medium density fiber cement, like Hardy Panel, has been used in residential and low-rise commercial. They are smaller panels. They require more support. Manufacturing tolerances aren't as tight, and you really have to make sure you carefully trim it so that water stays away from its edges. Now I'm just going to touch on how to design with fiber cement, and I'm getting close to the bottom of the hour, so we'll just work through this. So I'm going to talk about thermally broken facade, how to design this panel layout, etc. So I mentioned earlier rear ventilated rain screen. So we have a panel fastened to a girt with a cavity behind the panel, allowing ventilation, with a breathable membrane over the insulation. And then this is showing the old way we used to do things with horizontal Z bars. I'll be showing you the T-clip. And then, of course, the structure and air vapor barriers. So the T-clip is all about giving you a system that meets the new codes and creating a thermally broken facade. Non-combustible construction, adjustable system, and the key part for an architect is the substructure does not dictate the outside look of the building, which, believe it or not, a couple of the other product categories that are trying to offer you a thermally broken facade, they really actually tie your hands for what the outside of the building is going to look like. We needed to have something that was easier construction and cost effective too in order to build that growth in both for our install business, but also for moving the product across the country. It suits all structures, suits all insulations, all installations, and it meets the current way people put things on buildings. So we don't have to really worry about uh, changing or training folks. This is a good rendering of how the system works. This is just the metal, of course. So you have a T-clip on each stud that's thermally broken from that stud, and then thermally broken from a horizontal girt, and then the vertical girts and the panels. The location of those vertical girts is independent of the location of the clips and therefore the studs, so giving you complete design freedom across the wall. The substructure we tend to use is galvanized steel because it's inexpensive, manages thermal expansion well, it's simple, and so forth. We use an air out shield membrane on the outside of the insulation to keep the rain out but allow the wall to breathe. And that's a key aspect of rear ventilated rain screen. Now our design guide, which we have available on our website, just need to register quickly for it, covers all the different details. And I'm just going to touch on a couple of them. It covers the system, the girt spacing, the panel layout, vertical girt substructure, fixed and floating points, horizontal girts, etc. Now this is, and so that book is very, very thorough and it really helps you out a lot in your design decisions. I just wanted to paint a picture about this. An architect came to us with a layout for this hockey arena, and he had quite a bit of variation in it. So he had different heights, different lengths, really interesting layout. And we worked with that architect at ATRR and also at BBB to standardize it a little bit without taking away of his concept. So we ended up putting in vertical girts every 300 and then staggered the joints. And if you look carefully, you'll see this is a matter of about 4 or 5 different part numbers mixed up in a variation. And that mixing it up made sure that we had very high panel utilization. So we didn't have a lot of waste. And that's the kind of thing we can do with you because we understand the product so well. We can work with you to get what you want. So the types of things that that affect cost and panel utilization go as follows. So vertical girts are the key part. So we need to have some vertical regularity to help out labor costs. It takes a whole lot less to have an installer puts everything on 300 on center as opposed to having these vertical girts staggered all around. The horizontal cutting is pretty easy to make horizontal variation. And we look at panel utilization. The easiest way is to pick a factor of the overall width or height of a panel and adding that up. The direction does depend on your desired aesthetic. And as I mentioned earlier, the ether colored product has a variation in aesthetic and how the light catches it. So it's kind of up to you how you might want to lay it out to get the different looks. This is a cross section of the T-clip and how it's attached to a wall system. So we have the wall on the right-hand side, the sheathing, air vapor barrier, and the T-clip fastened to each stud. And then our horizontal Z-bar, which supports a breathable membrane, the vertical bar on the panel. And the key part for the installer is that this is adjustable, which is going to make sure that the wall that is not straight, and there none of them are, can be still constructed in a very timely fashion. We provide the load tables for the vertical girts and the fasteners. And so our design guide covers all of these topics, the girt spacing, the panel layout, the girt substructure, fixed and floating points, etc. It also covers all of your conditions so that you can understand how to detail. Now, these are done with respect to engineering, we can work with you to modify them for the aesthetic that you're trying to create. But our design guide covers what a plan view of the girt structure would look like. It covers the different types of girts. It covers what the window side would look like. And in this case, what we show is a trim that's attached to our system that gives a place for the window supplier to place his caulking joint. It covers outside corners, and the T-clip being so strong, we can cantilever our horizontal girts across and then tie it together with a vertical girt and the panel. And this really makes it simple to construct and very straightforward. So the book covers a whole lot of details and a lot of information for you. And we can also get into all of the other variants of products. So just to show you some examples before we say goodbye, these are some examples of laying out panels and fasteners that can change things. This was a recladding of an old office building up near the airport, and the old brick was leaking, as well as it really looked tired, and so recladding it has improved the rentability of this building. We can lay it out and cut it. The Facade product really offers a cool aesthetic. The bottom right is a house in North Toronto. We can do recladding of schools. A lot of the school institutions are getting old. They don't have the right R value, and probably the aesthetic isn't making people too proud to be in them. And therefore, the recladding of these schools adds a lot of value. Can be used on interiors, and we're seeing more growth in that space. Can be used in really unique aesthetics with this crazy assortment of punch windows. It can be cut very easily, and I'm kind of surprised this doesn't happen more often, but we could create a wall in front of a curtain wall and cut it and create a really interesting aesthetic. So that's definitely a point of creativity. We can create a situation where the returns on the windows are all fiber cement, and that's where you can add a dash of color in this case. All the white panels on this job out in BC are fiber cement, and very good for aesthetics and the weight of the building. And again, that white is going to stay white. And when you got a humid location like BC, that's a great solution because they're not going to have the dark black looks that you get on precast. And you get to do some cool buildings too, like 60 Richmond in downtown Toronto. A layout for YMCAs. We've done a number of YMCAs, which sort of proves its price point and cost worthiness for projects of this type. This is an interesting brow. We've designed and built a few of these. This is in Europe, but this has come up a number of times in order to really add an interesting aesthetic and accent for the building. This is a beach house where the shutters have all been made with fiber cement, and so the building kind of closes up into a box. This is an old house. I think it's in East Germany. And by building this entrance, completely changes the brand or the aesthetic of this house. The one on the right is a Canadian example, and the one on the left is an example in Europe. This is another example of using white fiber cement up in the Peterborough, Ontario area. Same white fiber cement in Durham. And thank you to the architects for whom I show these pictures. They've been great jobs to work on. And that's about it for today. Hope we've covered your thoughts and questions for fiber cement, and we'll be happy to help you out with samples and details and the design guide that I referred to in our discussion. If you have any more questions, I'll stay on the line a couple more minutes, and I'm looking at the question bar to see if you have any questions. Otherwise, happy Canada Day and have a great long weekend.